So in this video, I've promised to talk through the examples that are in the optimization booklet, which you have access to on our shared OneNote. So just recapping yesterday, we talked about optimizing business, and we talked about revenue being the money that comes in, and we called that R. And we talked about, in a simple case, if we have business that has units that they produce, and the cost per unit, say N being the units they produce and P being the price per unit, the revenue is just NP. We also talked about cost. Cost could involve multiple things. Could be employees, could be the cost of producing things, it could be the cost of the product. We have a cost. And we talked about profit. Okay, so profit would be the money that comes into the company, the revenue, take away any costs that need to go out, and that produces our profit. So the simple case, the profit is the revenue take away the cost. And we can also substitute this equation into this. So we have NP minus C would produce the profit. Okay, so the example that you've got in the optimization booklet says a small manufacturing firm can sell all of its production at a price of $8 per item. The production cost function for producing N items per week is given by this formula here. So we've got a cost function, and it's 100,000 plus 8N, take away 0.0156 N squared plus a very small number. I'm going to come off the end of the screen there, so I'll have to write it under here. 2 times 10 to the negative 6 and n cubed. Alright, what should the weekly production target be in order to maximise the profits? So what we have is a cost formula, and we're asked to maximise the profit. So we need to adapt that simple case where profit is revenue minus the cost. Now, the revenue, we were told, don't forget, that it was $8 per unit item. So our revenue is going to be 8N. That's the cost, 8N. And our cost function is already in terms of N, so our profit will be our 8N subtract all of this. So that's going to produce a profit function in terms of N. Okay, so I'll just write that one up. N minus this 0.0156 N squared plus, and I'm obviously, it's a good board because I'm looking at what I'm writing, brackets around that, N cubed, bracket around that because I'm subtracting all of that. Alright, well, when I remove the brackets, that's going to be minus 8N, so that and that will disappear, leaving me with just minus 100,000 minus the 0.0156 N squared plus the 2 times 10 to the negative 6 N cubed. So put that in brackets. Okay, hang on a sec. I need to change the signs of those because it's minus, so that becomes a plus, and that becomes a minus. I got struck then by the light. There we go. So that's my formula. Now, the next thing I need to do is factorize it, because I need to be able to solve for when, no I don't, I need to be able to differentiate it. So I need to find a function that I can differentiate, because that's what I'm going to do. I'm going to maximize the profit. So I've got to be able to differentiate this function, put it equal to 0 once I've differentiated it. So let's differentiate P of N. So P dash of N then. So this constant disappears when we differentiate. This term, we bring the 2 down, so I'm going to get 2 lots of 0.0156 N just on its own. And then that one, I'm going to bring the 3 down to the front of this number here. Leave it in standard form. And I've reduced the power by 1, so it's N squared. Working this out, well, 2 lots of that, so it's still on P dash of N. 2 lots of that is 0.0312N, and I'll leave that as minus 6, so I'm doing 3 times 2, 10 to the negative 6 N squared. Now what I can do now, put it equal to 0 because remember, when the gradient of something is equal to 0, that's where our maximum or our minimum is occurring, because the gradient at the maximum and the minimum is flat, 0. Put it equal to 0. So let's pull that out. Now let's pull a factor out. Let's pull n out as a factor. So if I pull n out as a factor, I get 0.0312 minus this number here, 6 times 10 to the negative 6, n. And that's that. Now I can use the null factor law. I can say either n is 0 or this expression here is 0. I'm just going to wipe off some of this board to clear the space so I can continue that. Alright, so I've rewritten that up there. So either using the null factor law, either n equals 0 or 0.0312 minus all this equals 0. So if we move that over to the other side, we get equals 6 times 10 to the negative 6n. And then n is just this divided by that. So whatever that is, I'll have to look at my working, we get 5,200. Okay, so n is 5,200. Now we've got to verify that that's a maximum, so we're going to use the second derivative to verify that that's a maximum. So because I haven't got the derivative up here, I'm going to have to look at my notes. The derivative of the profit function over the page is p dash of n equals 0.0312n minus this number here, multiplied by n squared. Okay, so that's our derivative function. Now, let's do p dash dash of n. So that just becomes 0.0312 minus 2 lots of, so that becomes 12 times 10 to the minus 6 of n. Okay, now if I just work out when n is 5,200, we can work out that if our derivative is greater than 0, then it's a local minimum. If it's less than 0, it's a local maximum. So if I work out what p dash dash of 5,200 is, it becomes minus 0.0312. P dash dash of this number is less than 0, so therefore we can say it's a local maximum. So to answer the question, which was what should the weekly production target be to maximise profits, it should be 5,200.